Everybody, thank you. Look at how timely we all are. Is this going to be like how this group behaves all week long? So like I said, I'm going to be your host, but before we get started, one of the important parts of this is you have to have somebody to sponsor this or this thing that really doesn't happen. And we are super happy today. We got Jonathan Simon with us from Flowguard Gold, and he's going to go up and speak for just a few minutes to us about Flowguard Gold and how it can help solve some of your problems, some of those hidden problems that we talked about, right, Jonathan?
Absolutely.
All right, so please welcome our host and give him thanks for sponsoring this event and this structure.
All right, well, it is truly a pleasure to be speaking with you as the sponsor for this presentation. Our message with Flowguard Gold is very much aligned with the broader topic for this group, Structures and Systems, and the rest of this presentation about building better homes. So I want to talk about building better homes with better plumbing systems. A lot of folks don't realize that water is one of the most destructive natural forces on Earth. You see the Grand Canyon photo in that photo, carved out by the forces of water over time. Controlling water is a priority in new construction. So vapor barriers, flashing gutters, all of these systems we put into place in our homes to keep water out. But what happens to the water that we're intentionally bringing into our homes, putting it under pressure, heating it up? That presents an inherent risk. And that is what makes plumbing one of the highest liability parts of a home. Folks might be surprised to know that the largest construction product defect class action settlement in history was polybutylene plumbing systems. It was over $2 billion, and there had over 300,000 homes had to be repiped. And since 2001, there's been at least 22 certified class action lawsuits involving materials like galvanized iron, copper, and PEX. And at least 39 builders have been named as co-defendants in this litigation for their role in selecting or allowing those products to be used. So why do class action lawsuits typically happen around plumbing systems? Well, number one, the pipe and or fitting material is not chemically compatible with the local drinking water. This is why builders are often getting brought into these lawsuits, because it's an issue of the product being allowed in the home not being appropriate for the local water conditions and the environment at the site that it's being built. This corrosion or degradation caused by incompatible water conditions leads to widespread failures. If you're having a failure in an individual unit, it's not going to result in a class action lawsuit. This is usually whole subdivisions, multiple subdivisions across multiple counties or even multiple states. And the warranty claims end up being denied by the manufacturers. And what you see on the screen there along the left-hand side is excerpts from the warranties of all the major PEX manufacturers, which specifically exclude failures caused by chemically corrosive or aggressive water conditions. So these are the manufacturers themselves of the pipe and fitting saying the water might cause our pipe to fail. In recent years, the majority of these failures and the litigation surrounding it have involved chlorine degradation in PEX plumbing systems. And this happens when the chlorine that's put into our drinking water to kill bacteria and viruses and other biological contaminants interacts with the cross-linked polyethylene at a molecular level. It ends up breaking down the carbon backbone of PEX and leads to these micro cracks. And you can see in the photos there, the top is what you can generate in a laboratory exposure, and on the bottom is what happens through a field failure. And we're going to pass around the room an example of the pipe that has failed, that actually came out of a home after about 6 years in service under normal chlorinated water conditions. The Plastics Pipe Institute has issued 2 technical notes on this topic. So first was PPI TN 53, which defines the limits of the chlorine ratings to which PEX is held. That includes temperatures over 140 degrees Fahrenheit, pressures over 80 psi, or highly aggressive water, as defined as having oxidative reduction potential, or ORP, greater than 825 millivolts. Two of those are somewhat controllable by a builder. The last one, the water conditions, is completely outside of your control. PPI-TN 67 cautions against the use of chlorine dioxide. And after this technical note was issued, two major manufacturers of PEX updated their installation guides specifically to recommend that it not be used, that their product not be used if chlorine dioxide is going to be in the water. There's really only one plumbing system that is guaranteed to be immune to chlorine degradation from drinking water. It's the only plumbing material that has 0 certified class action lawsuits over a 60-plus year history. Over that 65 years, with over 13 billion feet of pipe installed in American homes and businesses, and that's Flowguard Gold Plumbing Systems. So I know this isn't your typical sponsor presentation. I just dropped a lot of technical education on you. Really looking forward to meeting with you, helping you take control of the risk and build better homes. With that, I'll hand it back.
Oh, fantastic. That's great. Jonathan, I have to tell you, that was probably the best sponsor presentation I think I've ever actually heard. I actually learned something, and now I'm scared about all the PEX I put in houses in the past. So I was like, oh, God, I'm not sure I wanted to learn what you told me, right? But yeah, I may need a little bit of that, right? All right. Well, how many of you learned something from that? Yeah. How many are really happy you learned it? Yeah, me neither. But we need that, that's part of the process of learning as a builder. Right? We really need to understand what's going on in the business, what's going on with technology. And you're going to get a lot of that today. I mean, that's the good news about this session. Let me kind of give you some grounding here in what we're going to try to do. Today, right now, this is the structures and systems track. It's Tuesday, the 23rd. We're here. We started the conference. We're in the kind of new homes and better bones, muscle and sinew and skin. If you wonder, did I invent that? No, this is John. Okay, so John invents these kind of titles for these sessions. This is his session. But, it's really important because a lot of times when we start talking about the future of housing, we get all tied up in what we put into the home. The electronic door lock we're going to put on the front, or the entertainment system that we're going to put in, or the new kind of kitchen appliances that we're going to put in. The bottom line, though, if what we build is a basic home, what's behind the walls fails. All that other stuff that we've hung on, it really doesn't make any difference whatsoever. So we're starting this whole discussion with a good hour today, and we've got some tremendous people I'm going to introduce you here to in a minute to really talk about how do we make sure that we build a great home, great structure to begin with. And then we can kind of move on to the other things that we're going to put in the homes. All right, a couple ground rules. You're here because you really want to learn, right? We're here because we're trying to figure out how to be better builders and make more money and have a company that's going to last. So, let's make sure that we participate. If you've got questions during this, stuff's thought-provoking, or somebody says something that you go, well, I don't have any clue what he's talking about. That was half of what you said. But, I hadn't told them yet that they needed to ask you questions. Now they can ask you questions. Raise your hand. We have time. This is a small group. This is meant to be a small group discussion. We need to get to know each other. You need to get to know the presenters. You need to know each other at the tables. So ask questions, get to know each other, form relationships amongst your tables and the presenters and all that kind of stuff. Walk away with some action items. And I know our phones are a constant distraction. These are only 5 sessions. They're less than an hour. Try to get that phone put away for that 50 minutes, and as soon as you get out of here, pull it out and see all the messages you got. It's like an Easter egg hunt. I guarantee all of you are going to have messages when you get out of here. It's going to be so exciting for you. You can open that up. So I want to get to know each other just a little bit, though, right? And I like to do this. So I like to find out in the audience, so who's an under out there? Who's an under? Under or over? Only one under? No, you're kidding. Oh, well, we got an under, another under. Who's an over person? Yeah. We'll talk to the under people after this. Yeah, well, we'll get them straightened out. All right. Who actually doesn't damage their books and who dog ears every single page? Okay. Dog ears? Bookmarks? See, we're already mixed, right? I was with all of you until I found out you were losers about how you read books and stuff, right? God dang it. All right. Who's got the stickers on their computer still? Yeah. Who takes them off and polishes it and gets the goo gone and makes it all shiny? Yeah. Mm-hmm. There's some consistency here with you, man. Do you fold your toilet paper on top of that? Is it like you make a bunny and put it on top or something? Man, I don't want to live with you, right? Holy cow. All right, who just gnaws on the candy bar? Anybody? No, I can't do that either. Right? Breaking off chunks? All right, we're doing good here. And then last
Of us.
who wraps the gifts on like on the left? And if one man here raises their hand, I'm going to smack you. There's no, you're just lying. I know you're lying. No, do you really do that? You really? Oh my God. I can't do that at all. Mine are worse than what's on the right. That's my best practice on the right, actually. That's if combat. So you can see, there's multiple kinds of people. We're sitting here in Nashville, Party City. If you've gone outside, you've noticed there are a few bars within walking distance of this place. So there's going to be two kinds of people in this conference, right? There's going to be guys like you. You're going to make notes. You're going to go walk out of here. You're going to be a better builder. And there's going to be some other guys that we're going to find tonight. And there could be a couple of them in this room. I'm not sure, but there could be a couple of them in this room. So I hope you're all here for the left-hand reason. Yeah, this is it's a great group. It's a great venue. It's small. It's intimate. You've got great presenters over here that we're going to be able to hear from. So let's get started. We're going to talk about better bones, better sinew and skin, and that all gets down to what we specify, how we actually design homes, the materials we put in the homes, how we specify those materials. And there's a lot of questions that we got to ask. What is the new building science telling us? I did not know the new building science was telling us that chlorine is a major agent working against PEX. I didn't know that. And I'll bet 5 years ago we didn't know that, or 8 years ago we didn't know that, right? The science in our industry is changing, at a very, very, very rapid pace. How many of you have heard of swimming pool cancer? Have you heard of that? Yeah, it's crazy, isn't it? And yet 5 years ago, we didn't know anything about it. And now pool companies are going bankrupt and filing bankruptcy and all this because they didn't realize that the composition of fly ash mattered in the concrete mix that they got, and the cement contractors weren't telling them how much. So you put in a $100,000 pool and you come back 6 months later and the entire pool is trash. You have to actually excavate it, dispose of the whole thing, start 100% over again. It's just a disaster for the industry. What prevents that? Science. So we're going to be talking about building science here. So, what's the science telling us? How do we spec it, right? How can we get it, and how can we rely on who we get it from? That's a big deal, right? And then how do we get our trades to follow it? I've seen this over. And how many of here have seen in our drawings and specifications the right way to build a home, and yet when you walk the site, somehow that house doesn't look anything like what we spec'd, right? And put in the drawings. It happens all the time. And this is kind of our industry. We have an inspection industry. Somebody has to walk around to make sure we're really doing things the way we say we're doing. So how do we get it followed? How do we make sure that it's spec'd in every single home? We can have a best practice, and then, the new community opened up over there. There's a different architect, different plans. They spec a different product. It's no longer Flowguard. Now it's PEX. It just kind of disappears. It just kind of drains through your hands. So we got to figure out how we do that. So those are kind of the questions that we got to ask. And I will tell you, building science has changed a lot. I love this. This is Simpson Strong Tie. They built this 7-story apartment complex, 800,000 pounds, 23,000 square feet, put it on a shaker plate. And they simulated a 7.5 earthquake. Now this 7.5 earthquake, right? This earthquake was a California, Los Angeles area. What was that? Not North Cross. What was Northridge earthquake. That earthquake destroyed steel buildings. It destroyed concrete buildings. But this is engineering science. That structure passed completely in the test. Not only were the occupants safe in it, but they could immediately reoccupy that building if it went through a 7.5 earthquake. And they didn't stop there. They did another test. I think it's even more interesting. This is called the Tallwood Project. And you didn't you go to the Tallwood Project?
There, yes.
You actually were out there. This is a 10-story
The building
apartment
swayed
complex.
as it would have in the
Made
1999
100% with
Chichi
wood.
earthquake in Taiwan.
No concrete,
At magnitude 7.7
no red iron.
Quake killed
This is
more
a
than
100%
2,000
wood structure
people.
going through a
Buildings made of steel
7.7
and
earthquake. It
concrete
models the
were
earthquake that
destroyed.
took place in
But
Taiwan.
the wooden high-rise built
And when they
recently
got
at
done with
UCSD
this,
shake table showed no visible
It was completely
damage.
The
occupiable.
building is fine. We don't need repair.
So it just makes
Maybe
that the only thing they
crack
had a
some
problem with is
drywall, but
drywall on the
that's
inside
about
cracked. So you got to kind of go remud, and re-drywall. But occupants survive, buildings survive, don't have to tear it down. This is building science. Simpson Strong Tie, major partner in this. And you might be asking, well, this is all interesting, but our builders really doing this stuff. Now, I spent the early part of my career in Japan, and I actually had the luxury of studying Toyota because they have a home building division, if you can believe it. There's a company called Toyota Home, and they actually build homes in Japan. And there are other companies. There's Daiwa House, there's Sekisui Home, so there's a variety. Sumitomo builds homes in Japan as well. And one of those companies, Sekisui, has always impressed me because they're kind of engineering focus that they use. And Sekisui now is one of the largest builders in the United States. They own Woodside, right? They own Richmond American, Chesmar, Holt, right? So this is a huge builder. And they are bringing this science into all of the homes that they're going to be building here in the United States. They earthquake test their structures at a single family level. They're using the same kind of fastener technology that Simpson Strong Tie is recommending of how to make these structures resilient. They do complete fire testing of all of their exterior skins of their homes, so all of the kind of California wildfire issues and insurance issues. You're going to be able to insure these homes when you can't insure other homes because they've been tested to withstand that kind of fire danger. Impact testing as well. They even get into cold weather testing and hurricane testing of the entire structure, not the individual components, but the entire structure. So the building science that we're going to be using going forward is going to be informed by all of this kind of information. And I've already seen the presentations of these folks over here. It's fantastic. We got two great people from Simpson Strong Tie. We got Scott Lang here right in the center, and we got his cohort in crime over there, Chris Rizer. They're going to start, and they're going to talk about why homes fail, and they're going to show you the different kind of systems that are out there that can prevent this. And then we're lucky to have Conor Sedam with me, and he is from Higharc, which is a complete system to help you design homes, market homes, sell homes, build homes, and really go through the entire process. And they can help us make sure that every single home we build has inherited our best practices and that our best practices are being used and the trades in the field actually have that data at the fingertip. So I'm going to turn this over now to Chris. Come on up here, Chris. Give Chris a hand. He needs the encouragement. Come on up here. He's going to give you a lot of great information. You take it away.
Thank you very much. Appreciate you having me today. I'm a branch engineer for Simpson Strong Tie. I've been with Simpson for 3 years, but I've done a lot of things in my career, all residential related. Did EOR work, so engineer record work, designing homes, worked in the component industry as well. So hopefully I can bring some good information. And I thought today what I would do is, this is innovation, right? And it's engineering and it's technology. And I thought I would have a little fun with this, and hopefully you'll agree. I'll get your feedback at the end here. Let's look at some misinstalls and what comes from that, right? These are things that happen in the field all the time. They're issues. Your builders are there. They're trying to get these homes built, and we want a safe structure. But it doesn't always come, things don't get installed the way they should sometimes. And what do? We see that, we hear that feedback, and we innovate, come up with new ways of doing things that are going to have the structural integrity that you want and need to make your homes resilient. So kind of what's a misinstall, right? Putting that square peg in a round hole, or maybe we forgot something, right? We need some stairs, maybe. Or we're just going to change the intention of what we're supposed to be installing because there's interference.
I've seen Simpson Strong Tie hangers hung by the last two nail holes, because they're called hangers.
Yeah.
Right?
Just a couple of. So what are some of these misinstalls where maybe we're using the wrong kind of fasteners, or we're bending and making field modifications. Maybe we're using the wrong product for the job. Or we put too many products that are jammed together on top of one another, and there's a whole host of things that we could talk about. So here's a strap, right? This is on a shear wall. You've got overturning loads and high wind areas. Looks like it's been nailed, but I'm going to throw that red flag, right? Let's take another look at the replay here, right? So there are nails in there. And this has been designed to have nails, but are they the right nails? It looks like those heads are smaller than the hole, right? That's not good. See these kind of wobbling around in that hole, they could easily pull through. And so this is definitely a misinstall. These are supposed to be using 148 by 3 1/4 inch or 16D synchro nails. That's what we tested them with. And so let's talk about testing a little bit, and we'll talk some more in a minute. But these straps have been tested and designed and tested some more to make sure that they're gonna work. That's to ensure the safety of these buildings. We test it, we publish the data, we put it in a catalog, and then when it gets to the field, the person installing put the wrong material in there, the wrong fasteners, right? We need to communicate better. Or maybe we're taking products and we're modifying them in the field. These are twist straps and post column caps, and they're just bending the metal in ways that they weren't meant to be used, right? Or, we kind of put the hanger up there, but it was in the wrong spot, so we just kind of cut it in half and threw the other part away. It's not really supporting that joist, right? The only thing supporting the joist is the toenail at the bottom, right? That should wrap around and hold that joist. So that, not big innovation there, right? We should install it proper. But here's a situation where we're attaching a truss to the wall, at the top of the wall, and then we're also attaching the top plates of the wall to the stud below. But all kind of happens and jams in together, right? Now every 3 studs, or about every 2 feet, or 4 feet rather, that can happen. If your trusses are 2 foot on center, your studs are 16 inches on center, every 3rd stud they kind of align, and so that engineer spec to 2 different connectors, and they actually overlap. So what did Simpson do? We tried to come up with a better product. We kind of merged those 2 straps into one part. So innovation, right? We see misinstalls, we see issues. We want to come up with a better part, a better solution. What about wedge anchors near the edge of concrete? Anybody ever see the concrete spall out? When you crank those wedge anchors and it's pushing all around on the side of the concrete, it'll spall out. Not the best product for that condition. Wedge anchors have a place, but usually not near the edge. How about, here, what do we see? This is a hold down, right? So we're holding down some tension, and for some reason, the installer decided to put a couple of small little dinky screws in the pilot holes. Well, we don't show those are pilot holes to help with manufacturing. They're supposed to be big bolts in the big holes, right, to get that uplift. So again, we need to be communicating better on materials. So here we've got some truss to wall connectors. They overlap, right? Not good. And then here's our H10S solution again. Here's a shear wall. So this is kind of a great product, right? We build houses more and more. We put more windows and doors and leave less segments of walls, because everybody wants a nice view. And so here's a great innovative product. But it has to be installed properly, right? These anchor into the concrete, into your foundation, and they should sit not on a sill plate, but right down on the concrete, right? And that's what's wrong here, right? Just not following the instructions. So luckily, we have solutions, engineered solutions to work with these scenarios, but this is a case where innovation has been created, but then we haven't educated well enough all the way downstream through the builders and through the installers. So great products, but we need to make sure they're being installed properly. Here's another one. These are clips that we use to attach truss to non-load bearing walls. Right? We don't want those walls wobbling around. If somebody leans on it, puts a ladder on it when they're painting or what have you. But if it's not installed properly, and they really seat those nails in there too tight, then when things start moving, you start getting squeaks. So if you're a warranty person, you hate that, right? So what is an innovative solution that Simpson came up with? we've come up with some screws that are in a plastic sleeve, and that sleeve is installed into the top plate, and the screw can move up and down inside that sleeve with no squeaks. Right, eliminate those warranty issues. So we're constantly listening and talking to folks like yourselves, asking, where are your pain points, or what kind of red tags you're getting on the job. Those things we listen to, and we try and come up with better, innovative solutions. We do that through great ideas from the field, but we also do a lot of testing. And so here's an sample of Simpson's laboratory or testing lab out in California, and we're testing 3-story wood frame walls for lateral loads here. So you saw the video earlier where we built the big structure and put it on a shake table. We do this kind of testing as well for shear walls and all kinds of product development, and we want to support the industry through great engineering, good innovation, and testing, as well as technology. And then I just want to talk a little bit about technology. Simpson's maybe not known for being a technology company, and we're working really hard to change that, right? Technology is the future, and that's kind of what drives a lot of the design process, the build process, and you're going to learn a lot more about that as we talk here in this group, and then other groups that you talk through this week. Lot spec, option management infrastructure for AutoCAD and Revit. So we basically design the house with all the bells and whistles, all the options, all the elevations in the computer, and then we take that model and can do so much stuff with it. And then here's a rendering of what the house really looks like when it's done. Pipeline is another great tool that we have that helps manage estimation, costing, and purchasing, to name a few, and it's really powerful. We'll learn a little bit more about that here in a bit. Simpson also has all kinds of software, web applications that anybody can use, free of charge. You want to know how to connect one board to another board, one truss to another truss, a beam to a beam. We've got web applications that can simply put pieces of your specific geometry and materials, and it will tell you what solutions are available. Post a beam selectors, another one. Anchor reference tools. So you're in the field and maybe your installers installed something that wasn't specified. We were talking about that earlier. Perhaps a tool like this can help you. This is what was specified, and then here's an optional product that may be used. So if they installed something that was wrong, maybe you can still justify that installation. Coil strap calculator. So I see coil strap specified in lots of places, and how much should you buy, right? Do you buy the 50-foot roll? Do you buy the 150-foot roll? You want to be efficient, right? How much adhesive when you're drilling an epoxy and in anchors? How much do you send out to the job? So great estimation tools, right? You put in some information, it'll tell you how many tubes of the different sizes that are available to you. For designers, right? So not just for the field, but also designers. We have plugins for Revit and AutoCAD for many of our products. You just plunk those details right into your plans. If you're an engineer and you're sizing anchors into concrete, we've got tools to help with that. Same with the bracing, wall bracing, shear wall design. We've got a whole host of things for that as well. Fastener designers, we offer many types of fasteners, and we can help designers with that. Hold downs, same thing. So the point is, for me being up here, is to tell you that we want to partner with those that want to build safer, stronger structures. we are very proud to feel like we offer many products to help make that happen. We try and innovate and listen to what feedback you give us in the field, so that we can solve those problems when they come up and have better solutions. We see the technology in the future is where it's going, and we want to be a part of that to make things easier and to evolve into a streamlined, efficient process for you. I thank you for your time. If there's any questions, we'll have some at the end, and I look forward to hearing those. I'm going to turn it over to Scott, who's going to talk a little bit more about some of the technology.
Great job.
Thanks.
Button were you pushing?
The big one.
The big one? All right. All right, I'm Scott Lang. I'm the technology guy with Simpson Strong Tie. As Chris said, we are a technology company, not just stuff that our core products was go in the house, the anchors, the fasteners, the hangers, but also technology of the digital source. So, here we go. So we talk a little bit about how we want to enable safer, stronger structures in a consistent way from a design perspective, right? So how do we get that each and every time? You know, I work with builders across the country. I know in some areas, every construction document has to be stamped by an engineer. Other areas, you know, I'm in Indiana, we could walk into the building department in the morning with a napkin, something drawn out on it, get an approval and start digging in the afternoon, right? So there's all different levels of municipality regulations that we have to build to, but I think what we're really excited about is using technology to know no matter where that house is going to get built, the technology is going to drive a safe, stronger structure, right? So we are using modeling. So how many of you have heard of Revit? Most of y'all have ever heard of Revit, right? So it's kind of the next generation after Auto. Y'all have ever heard of AutoCAD, right? So with Revit, we've got some plug-in tools that help it fit for home building. But in general, as we look to the future, we're looking for ways to make Revit more automated in the way that it places, they call them objects in Revit, out of families. But how can we use, let me go to the next slide here. How can we use things like AI and machine learning? How can we use our relationships with engineers and our relationships with software developers like Higharc to come up with systems that are intuitive and by default build in safer, stronger components and objects? So we kind of have a great position in the industry. We have relationships with pretty much every one of the builder in the top 200. You know, we're on their job sites every day. We have relationships through structural engineers. So we spend a lot of time in architects' offices and structural engineers, helping them understand how to spec our products. We also have relationships with pro suppliers, BFS, USLBM, 84 Lumber, Carter. So we're kind of sitting in the middle of all this, and they're designing your components. So we have a pretty good perspective and a lot of respect in the industry. And so we think leveraging guys like Chris that really understand the engineering, and then using our technology to partner with existing platforms to say, how can we build, you know, I'll steal a little bit of Higharc's thunder here, but you know, they're very, it's a program. It's very programmatic, and he can talk more about it. But if I draw a box and I say this is a garage, you know, I should be able to know structurally what that means, right? Based on where the house is going to be built, what the foundation is going to be, and all that. So, you know, our efforts have been not only to bring LotSpec, which is an option management software, but also how do we make our tools through programs and AI and machine learning more about embedding that safer, stronger structure components. And so we've got, Chris shared with you, we've got these, we call them web apps. So we already know if you give us the conditions, we can show you the lowest cost of install that meets whatever engineering requirements are there. So we know that. We know the content of a Higharc or a Revit model that would match that. So we can kind of marry the two, use the web apps to find it and get the actual Revit file for that, or if it's AutoCAD, and then place that product in a manner that meets code. So that's what we're doing from a digital, we call it digital technology now, from a software and services side, is we're really trying to marry, Chris's engineering knowledge through our web apps with tools like Higharc and Revit, so that we can embed by default, the objects that make the most sense. So, yeah, that's
what a great lead in. All right, let's give Simpson Strong Tie a little love for that. That was a good deal. Hold on, I'm going to introduce you. I'm going to introduce you. And that's a perfect lead in, because we know that the science is out there. We know that the individual products are out there to build great homes and structures. The challenge, though, gets to this last piece that, Scott, you started to touch on. How do we automate this? How do we get this into the DNA of all of our drawings and of all of our specs without hoping that our architect just happened to remember that, or somebody out in the field or our trades happen to remember that? So coming up here next from Higharc is Conor Sedam. And when I didn't know him before we started having our little chats, prior to this. A lot of times I'll talk to folks that are at technology companies coming into the builder space, and I'll kind of go, well, I'm sure they know the technology, but what do they know about building? This is one of the problems, right? And but I found out that Conor comes from a family of home builders, and I thought, well, that's really encouraging. And then I found out, well, on top of that, he's been a home builder himself. You're out there in the field doing home building, so he brings a lot of his own personal knowledge and experience of what you all, live every single day into the technology world to really inform a brand new product that at the very heart of it, at the very core of it, is really learning to design with a single source of truth. And it's a phrase it's used a lot kind of in the technology world, and it's something that I know Higharc kind of has embraced, which is, can we somehow have one single source of truth that we use throughout the entire construction process? Can we have a way of doing things that a best practice that inherits to every single drawing, inherits across our collections? When we go from a 3-car garage to a 4-car garage, when we change that plan left side, right side, when we add the bonus room upstairs, are we automatically inheriting all these best practices? So, Conor, why don't you take them through what technology can do for us today?
Thanks. Hi, everybody. I'm still very semi-uncomfortable with my customer marketing manager title, as I am a simple home builder. I started out with a national builder 23 years ago doing warranty work, and I was just thinking about building homes the wrong way. And the phrase I always remember my first PM told me was, build them up, fix them up, buy them a puppy. And my job was to buy them a puppy, right? Fix everything in the warranty phase. So like I said, or like Tim said, my name is Conor Sedam. I've been with Higharc for about 3 years. Before that, home builder. I worked for a couple custom builders, a large national builder, and ran construction for a local builder. Does anybody know what this phrase means? Have you ever heard that before? It's one of the funniest ways to describe this concept that I've ever heard. Just put it all in there. That way, if the contractor screws it up, we can just point to the right detail and say, it was there, you just looked at the wrong one. Anybody doing that still? Hopefully not. It was one of the funniest ways of saying, if we just put all the information in there, then it's not our fault if they use the wrong information. Anybody doing this to create lot specs? Instead of making an actual lot spec with just the details we need? Anybody ever X out the wrong one? I did once. I built a 2-story house instead of a single-story house once. True story. And then strangely enough, we offered to just give the guy the house for the same price, and he declined it, which is really weird. This made me think of my scopes of work that were tucked safely in my office, on the top row, that probably nobody ever looked at. Anybody do anything better with their scopes of work yet? Getting them out into the field? Or do we just put them in a binder and we just go, yeah, they're there, and then we'll look at them when somebody screws up? So the idea here, hopefully, what we're trying to do in the future is get rid of, maybe we can get below a 40-page plan set. Maybe we can get rid of unnecessary and outdated information or wrong specs. Maybe we can stop the hatred between the builders and the architects. Maybe we can come together and get the information out into the world in some sort of repeatable manner. That's kind of what we're trying to do at Higharc. It's what brought me to Higharc is, I've been trying to solve the same problems in home building for a long time. And when I saw what Higharc was trying to do in terms of kind of connecting this stream of information, it was just really interesting to me. So we know the products we want to use. That's what these fine gentlemen were telling us about. How do we communicate these things and get them out to the people that actually need them? And that doesn't mean on the scopes of workbook, or it doesn't mean in a 200-page master plan set, because nobody's looking at those. Bones, sinew, skin, all of that stuff is controlled by one thing, right? It's controlled by a central nervous system. And that's what we really need in order to make this information repeatable. It does start with tribal knowledge, right? We all have in our individual places across the country, our regions, even down to an individual plumber and an electrician or a framer. There's tribal knowledge that's inherent in home building. How do we get that out of people's heads and get it across our organizations? That's only gonna lead to, we always want the best crews, right? If you have the best crew, you're gonna build the best house. How are you gonna get the best crews? Well, you can either get the best ones, or we can figure out how to make more of the good crews, best crews. That's obviously gonna lower your warranty costs. You get higher referral rates. Just a little funny picture there about that. So what I like to think about in terms of how we're trying to solve this problem is we need to reinvent how we think about things from design, and then everything moves forward from there. Like Tim said, a single source of truth. So it starts with intent. How do we get the right products? There's great companies like Simpson Strong-Tie. There's architects. There's designers. There's people that know these things. And I know there's tons of talk about AI right now, and we're utilizing AI as well. But something that AI can't quite replace yet is figuring out, without any outside intervention, what is the thing we need to use? What is the best product for this application? It might get there someday. I hope not, because then none of us will have anything to do. But so how do we do that? How can we combine things like drafting, estimating, purchasing into one platform? The way we try to do that at Higharc is Higharc was designed from the ground up for residential home building. So what we try to do is, if we build this model, let's just keep everything in-house. Let's have the model know that a garage is a garage, like it was mentioned before, and let's have it understand what are the estimating and purchasing outputs that a garage entails. Of course, we got to talk a little bit about generative design. How do we allow professionals to spend more time doing the things they went to school for? That means, how do we allow architects to actually design homes instead of drawing lines? It starts with data modeling. Instead of just drawing a bunch of lines, have a house know that when I draw a living room, that it should have 3 windows on the back of the house, or that it should have a minimum defined space, or that a bathroom should automatically place a sink for you. Everybody knows a bathroom needs a sink. Everybody knows a bathroom needs a toilet. Why do we need to place those objects? Why can't we have a system that generates those objects? Then we can adjust them, but instead of starting from 0, we might be starting at 80%. We're starting with all the pieces there, and then if we want to adjust them, we're paying designers and architects to make decisions, moving things or placing them, making them better instead of starting from scratch. Another really interesting we're working on is, how do we cut the gap down between making mistakes in the design process? So how can we use AI to do things like automatically ask questions about codes, instead of having to go and have somebody know that code information for a specific area or a specific municipality? We can build a house, and then we can use an AI co-pilot to ask certain questions about that home to make sure it will be right. So we're not going back and forth with the building department and trying to remake those decisions over and over based on different municipalities. And finally, agility. How do we leave out the stuff we don't need so that we can be faster? Going back to that, 200-page master plan set example. The way we look at that is, how do we use a central data model to get information out faster? It's kind of a classic example of, hey, we need this information. We're trying to get this information out to all these different parts of the country. Some of them are going to have different architects that are going to have different requirements in different areas. How can we centralize all that information and then send it out to the places we need it automatically? And that's basically by centralizing our data into one location instead of a kitchen being a part of a specific house. Why can't a kitchen be a kitchen? And then why can't we say, we want to deploy this kitchen across 30 different plan sets if it fits? And if it doesn't fit, fine, we'll make a new kitchen. But instead of having 30 kitchens, now you might be able to have 3 kitchen layouts that you can just deploy. So obviously that's going to speed things up a lot. And then the only other, this is my last slide, but something that Higharc specifically isn't working on, but that I think is really cool and really interesting is this information gets us a great plan set. It gets us a plan set with the right details. It gets us a plan set without the wrong details. It gets all that information to sales and marketing teams. It gets us things like automated brochures, downloadable lot specs, all that kind of stuff. But I think something that is really interesting is that we can have the right products, we can have the plans to tell us how to build the right products, but how do we get that information out actually into the field to the people who are actually going to build these things? This is a mobile application by a company called On3, and I don't work for On3, but I just think it's a cool thing if you guys haven't heard of it. But the ability to basically mobilize your best practices. How do we install an SST product the right way? Using technology, getting a guy with a hard hat that's got a built-in camera on it who can show us how to apply waterproofing or drain tile the correct way. So that's just a little nugget on the end of it, but I think this topic overall is just so cool. And thank you guys for letting me be a part of it. I think the combination of the materials and the technology to get those materials out into the world, and then things like this where we can utilize our trade partners to help us install those things correctly is the kind of conglomerate and how we bring it all together for the future. So thanks.
Way to go. All right. Well, now we're going to end up with the next section of this little thing, which is Q&A. And I know what you're saying to everybody. I don't have any questions, but we are going to. So I'm going to kick this off. I'm going to ask a couple questions. When I'm done asking my couple questions, it's your turn. So you got to be thinking about what do you want to ask these guys up here. So the first thing that struck to me, I built some homes in my lifetime too, and I can't say that I was proud of every single thing that we did while we were doing it, right? I could look at your presentation and said, I've seen some of those problems. First of all, have you seen on your job sites any of the problems that he's shown? Right? We've seen it. So in my mind, I'm going, well, how could you help me understand where I am? How could I engage you? How could you audit me? How could you help me be a better builder? How would I engage you? What would that look like? How does that work for a builder like me or anybody else in this room?
Well, I'm glad you asked that question. Simpson has so many people that we put in the field engineers, branch engineers like myself, technical sales folks, training. We have a whole breadth of folks that focus on just that, right? We engage with builders, we engage with specifiers. So one, we want to make sure the right things are specified. Two, we want to make sure that the builders understand what's specified and how it should be installed. And then three, we want to engage with the installers and make sure that the ones that are doing it really know. And we do that through collaborative efforts with all those folks I talked about. We'll come to your job site, bring your framing crews, bring your concrete folks. I'm in Florida, so we do some stuff with concrete as well. And we'll work with you, right? We know where these things can go awry, and we are more than happy to help engage everyone up and down the build work stream to build that better, stronger structure in the right way.
So as a builder, you'll come and look at how I'm building, how I'm speccing it, and work with my trades to solve this problem.
100%. spent my last week doing
and
that.
who would we contact to do that? I mean, is there a 1-800 called Simpson Strong Tie? I mean,
Yes, you could
is
do
it my
that.
sales guy? I mean, who, you know, maybe I don't do a lot of business. with
You
Simpson
want
Strong Tie.
to jump in there, or I can answer if you'd like.
Yeah, go ahead.
So yeah, if you don't have a Simpson person talking to you, on a periodic schedule, that'd be the person to talk to if you do. But if not, yeah, call the 1-800 number for Simpson, and we will get the right people right out to you pronto to work with you to find those best practices and training opportunities.
All right.
Quick add on to that around technology.
Absolutely.
One of the things that we're trying to do, thinking about doing, is on the construction document sets, embed QR codes. And so if a guy's in the field and he's not sure how to install, he opens up his phone, he scans the QR code, and it takes him to an installation video that's specific to that, whatever was called out, whatever hold down or whatever fastener. So things like that we can do through technology that make field work more consistent.
So that kind of is, I have a follow-up question here, which is, you showed me a lot of misinstalls. And it's a problem. I could have spec'd it right. I could have wanted it to be built right, but it wasn't. What are some best practices? And this is for both of you. You've been a building manager for a long time. A process manager. So, what are some best practices to preventing misinstall?
Go ahead.
By the way, don't start with guns.
Yeah.
Okay, let's not start there.
Somebody last week, I was talking about how we used to have safety meetings, right? Like on-site safety meetings. And somebody was like, "You guys actually had those?" I was like, "Yeah, we had them every Friday." And it was like, "You had them on Fridays?" I was like, "Yeah, that's how we made sure people showed up on Fridays." But I think there's no substitute for obviously hiring the best trades. And then working with your trades to learn from them. One of the best things that my company, when I started out with, made me do is we had to go spend a week with each trade. And I think the more we can educate ourselves on what our trades' best practices are, the better we're going to be as builders, and hopefully we can learn from each other. It shouldn't just be a one-way street. In terms of how we approach those things at Higharc, for best practices, it's making sure that, like I tried to talk about in the presentation, but making sure that you're only sending out the right information, and that information isn't getting lost in a slew of other stuff that doesn't matter. That's just basically cutting through all the crap to make sure what's important is important. We do things like if you select a certain kitchen, when that kitchen detail comes up, we can automatically propagate a note that might be specific to that community about that kitchen. So trying to tailor and customize the data for a different region, or a specific house, or down to a specific piece of that house is kind of the way that we approach that.
I'd say we do three things. One, we have something called the Builder Learning Center, which I think we've talked to you about it. I don't know, but it's a free, there's 30 some videos, and it's not, hey, all Simpson stuff, but this is boring and notching, right? So we make that available to all the builders for free, and we're always adding content to that. A second thing we do is we're proactive. We'll have our field people say, hey, let's do a lunch and learn. I was walking through one of your job sites, I saw a misinstall. Let's just get everybody in, we'll buy lunch, and we'll spend 45 minutes or an hour doing a lunch and learn, and kind of really socialize how we think this problem can be addressed. And the third thing is just job site walks. We're just out there in the field, walking the job sites, and we try to be very good at when we see things, we say something. So.
All right, I got one more question before we're going to go out to the audience here real quick. AI is a big deal, but AI has to use data. You brought up a really, kind of a hot button issue around, codes. And when are we going to have codes embedded in whatever drawing tools and architectural tools that we're using? So it will know, nope, can't do that here. You got to do X, Y, Z, just automatically have that knowledge. My guess is Higharc's not quite there yet for nationwide, every code, in every municipality. When do you see kind of that level of artificial assistance in drawing tools that will allow us to kind of just naturally be notified that we either did it right or we didn't, or there's something missing in our drawings?
I don't think it's going to take long. We were working on a marketing thing about it, a new thing, and I asked ChatGPT to rewrite the lyrics of "Wanted Dead or Alive" by Bon Jovi. Everybody knows "Wanted Dead or Alive" by Bon Jovi, but with home building related lyrics. You know, I probably could have done that. It would take me 2 hours. ChatGPT did it in 30 seconds.
Yeah.
The pace at which all these things are happening. 2 months ago, the little GIF I put up, or GIF, depending on, I don't want to leave anybody out.
Yes.
That should have been on your.
It's both.
Of being able to ask if a window is code compliant. You know, that didn't exist in Higharc 2 months ago.
And it does now.
And it does now. And all that basically we needed to do was drop the code book in and be able to reference it. So it's not years.
You know, I saw something really interesting a couple of weeks ago at South by Southwest, which is a kind of a big confab of technology and everything else, and Icon, which is kind of the premier 3D printed structure manufacturer in the United States. They launched a tool called Vitruvius, and it's an AI design tool. And I'm sitting here, and they go, "Oh, you got this new thing? It's Vitruvius. We're going to show it to you." You know, thousands of people in this audience were watching this thing, and I'm going, "This is going to be bullshit." You know, I'm just ready for the. And he goes, "Okay, this is going to be a live demo." And I'm going, "Yeah, live demo. Like, yeah, I've got it all scripted here. I'm going to live ask it the exact 5 things that it can do." And he goes, "No, I mean live demo. Like, we're just going to ask the crowd what questions we're going to ask and go through this thing." I'm going, "Okay." And then, so he goes, "Okay, what kind of home do we want to build? Are we going to live in it? It's going to be a vacation home." And, "Oh, no, let's do a vacation home." "Okay, where's it going to be? Is it a forest, beach, mountains, lakes? Like where are we going to build this?" And they literally just asked the audience to, all these kinds of questions. And they had a guy on stage, and all he did was type that in. "I want a vacation home in the mountains." And within 30 seconds, not only did the rendering come back, but all the interior photos of that property came back. And then he said, "Oh no, let's do it in Scandinavian architecture instead." And 30 seconds later, that house was done in Scandinavian. "How about modern mountain?" And now it's done in modern mountain. And where they're going, their next thing is for it to produce all the construction documents automatically. So you literally will just sit there and say, "I want an Italian Renaissance single family home, like 6 bedrooms. I want a lot of outside space. I love outside stuff. Blah, 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 blah. It's in Vegas." And it will build it. And then you can sit there and say, "How about a tile roof?" Or "How about this?" Or "How about that?" Or make it. And it literally was changing in front of you. So it's just a neat thing to kind of go out there. If you go out online, there's a lot of YouTube stuff on it right now, but it will give you an idea of kind of where we're going, the power of artificial intelligence and what it will be able to do for us eventually in code compliance and drawings and automating all this kind of stuff. All right, go ahead.
That probably makes us all a little nervous, but
Yeah,
also one of the things I think we all love about home building is that there's no robot plumber yet.
Not yet.
We're still building a physical product that exists in the physical world that I can still drive by 30 years later. And we can start to replace a lot of these things or make these things faster. What I think is important to remember for now is hopefully what we're doing is we're giving people more time to do the aspects of home building that they love instead of spending time on the mundane tasks that don't matter.
It's interesting at that conference, there were a bunch of people talking about automation, AI, robotics in home building. And that was really the takeaway. They said, it's not about robotically building the home and replacing all humans. It's about freeing up humans to do what only humans can do. And yet a lot of the work that we do could be done by machines. right? So how do we free up that work so that we can actually do the higher value added and more creative and more interesting work? All right, so we're
Can I-
going to
just one more example on that.
yeah.
So this is a little bit more practical. So we've been working with Autodesk quite a bit, and one of the barriers for the builders I work with is they have hundreds, if not thousands, of plans in old 2D technology, right? So it's hard to do a lot of the stuff we're talking about. So the concept of using AI and machine learning to convert Autodesk AutoCAD plan library into something that's usable in a 3D model, whether it's Higharc or whether it's Revit, I think would really open the doors. And it is a data machine learning iterative process that I think it fits really well. So I think in a more practical sense, for builders that are looking to get out of 2D and they feel like the legacy product has got them kind of locked into it. I think not too far down the road, we'll be able to use tools like that to change, because we're different than any other company that uses these design tools, because we build the same thing for 10 years over and over again differently. And so all this legacy product needs to be converted for us to be successful. So I think that's one area.
Yeah, it's interesting. Talk about Autodesk. I had seen the demo a little while. They were using airline seats as an example. And they kind of showed, here's all the airline seats kind of that are out there. And they're either kind of welded or they're cast, or, the frames at least, right? But they're all pretty pedestrian. It's kind of like if we all sat down in a little workshop with a blank piece of paper and said, can you design an airline, a seat frame? We'd go, okay, well, they got to have 2 rails and they got to have cross members and probably have a shear bar, right? Right? You'd kind of sit there and we'd all figure it out. And they all look pretty similar. And it's just a matter of whether it was cast or whether it was welded or, whether it's tubing or square or sheet metal or blah, 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 blah. But they then enabled their AI designer and they said, all we need to tell it is what size does it need to be and what loads are on it. And then it went through and auto-generated all these organic designs that were completely different. Just fundamentally nothing like you would have ever noticed. And the winning design in the end that actually is getting implemented by the airline, it's just kind of mosaic of forces with holes in it that you would have never have even dreamt of. But it was lighter, stronger, cheaper, in the end. And I think that's the issue of when you can sit there and go through millions of permutations in seconds versus what we can do as humans, that's just an incredible opportunity for us. All right, let's open it up to the audience. We got to hope there's some questions out there for anybody. General questions, specific questions, could even be for our Flowguard, our sponsor over there, like, well, what do we do once we've already installed PEX and we know we have chlorine in the water? Something like that,
I've got a question.
You bet.
So, Scott, this is kind of a feed off of, or how did that work?
Yeah, I think probably a lot of y'all have worked for different national builders if you've worked, but every national builder is different. Like I know your company is that kind of top down. We want our divisions to use as much as they can, and we're gonna leverage this. Other builders are like every division is its own P&L, and I don't care what you do as long as you send that check to me. So it's a discovery call, Butch, right? It's understanding. We have the technology to do both. And what we try to do is we try to figure out what's the optimal level of reuse where it's not getting too complex. And so, and I think Higharc would answer the same way. It's really about understanding your business model and then understanding the ability of your software to handle complexities and when it just gets to be too much.
Okay. So essentially you can work with us wherever we just make sure that it's an open air conversation.
Yep. Yeah, we've been doing it for, at CG Visions we've been doing this for 25 years. So we tend to have a high interest in understanding where you're at and then moving from there.
We do that with templates. So, we can have template A, which specs all of these products, template B, which specs all these other products. And then you could have, the Hartford home over here, we want to use template A here. Over here in the Hartford home, we want to use template B. So we can design basically, as opposed to saying, these are all the products that go to this house. These are all the products in this template, and now we're going to apply this template to all these houses. It's kind of how we approach it.
Right, and say for legacy homes for us right now, the template would be you have C to, CZ, if you will.
Yeah.
Every home, and that's going to be a different fashion than legacy. Right? So just trying to understand that, right, and making sure that the best practices would either fit ours, number one, or secondly, where we're trying to really go to is getting down to that base and really being able to understand base space and understanding our options and being able to really work with you guys and more cohesive.
I think there's like a fundamental shift that has to happen, which is the data doesn't have to be part of the home, right? The data can be applied to the home, depending on where it is and what it needs. So that now when I'm talking about swapping out windows, I'm not talking about swapping out windows on, plan A. The window can just come from the central data source and be applied to plan A.
So for example, I could have a PEX water delivery system and I could have a Flowguard water delivery system. And I use Flowguard in all of these conditions.
You should use Flowguard everywhere.
Yeah. Afterwards, there's some money being transferred here, right? But I'm just saying, right? You could do that, right? You could sit there and go, look, we use Flowguard. We use Flowguard in all of these conditions because we don't want the liability, whatever. That's A. And B, oh, by the way, we have this other low-cost system that if the water conditions happen to be right, blah, 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 we have this other detail that we can use as well. And you just decide then based on the conditions, right? And same thing for seismic issues and, right, all that kind of wind, seismic, blah, 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 and local codes, which are driven by all that kind of stuff. All right, another question. We got at least time for one more here. Yeah, we got at least one more question here. Oh, come on. You got to ask something. There we go.
So, speaking of the legacy plans, and you mentioned the upcoming AI that will pull the data quicker, establish it into the systems quicker. What's kind of the turnaround time for, say, 5 plans of legacy plans to get into your red or your Higharc or into the system now? What does that look like time-wise?
So you're saying not using, but like in today's, like if we're to kind of like brute force? So that'll be really dependent on the complexity of the plan more than anything. If it's your value line and it's 3 elevations and maybe just 2 or 3 structural options, we can turn that around. Now we need to bring in structural engineering because we don't do that. We just do the architecture part. But probably 4 weeks, 3 to 4 weeks. If it's a Taylor Morrison high-end product, then it's going to be probably double that. So it's and one of the things that we try to do is we try to establish a standard so that if we can't handle all the work, then we have partners throughout the industry, Fieldstone, BSB, some of those. So if it's a matter of, volume and you need to get done, then by having more of an industry standard in the way that we work, we can pull in other resources to do it.
We did a cool webinar I got to host about a month ago where we actually sent out an email, asked for builders to submit their plans. We had a builder submit plans, and we did kind of what you were talking about before. We did a live implementation of a plan in an hour. We're live in front of the audience. We said, okay, now what do we want to add to this one? All right, I want to put a second story on it, or add a 3-foot bump out in the kitchen. And we were able to put a plan into Higharc and have it be able to be, walk inside of it in 3D, rotate around it, generate building materials off of it, generate a plan set off of it in an hour. Was it fully scoped out and perfect and would I have taken it in for permit that day? No, but it's getting faster and faster to the point where if you're trying to figure out if a plan is viable in a certain location, if you're trying to figure out if you can make money off of this specific concept that you're trying to build, to be able to do that in an hour and have a better than back of napkin, be able to see it in 3D is pretty cool. And we've got some clients now that will actually do their kind of creative design live. They've got people that are trained to use Higharc, and the CEO will come in with his hand sketch. They'll put it in and they'll have it up on a big screen and go, okay, well, we think we need to change the roof pitch, right? Just change the roof pitch then. We think we want to add a 3-foot bump out option. What's that gonna do to our overall cost per square foot, that kind of thing. So it's getting faster and faster. I think as the AI stuff comes into play for all the legacy plans, it's gonna get even faster. But yeah, it's pretty cool stuff. Certainly, it's not months anymore. It's down to hours or days.
All right, we're going to have to wrap here, but if you had one thing to tell the audience of something that they should try, think about, do, something they should remember, what would it be?
Being selfish for Simpson, I'd say we're we're available to you to help you build better, stronger homes and take advantage of our resources. Yeah.
Scott?
We're not just metal. We have a really strong technology, digital solutions program that would get stronger and stronger. So
think about the digital.
think about the
side.
digital
Think
side
about
of it,
the
not
digital
just
side of the business.
the holding the house together, but how you build it.
I'll steal mine from a mentor, but you can have as much complication as you want in home building. You can have as many options as you want in home building, as long as you have the processes and systems to handle that complexity.
Oh, that's interesting. That's too deep for us.
I didn't know that.
Yeah.
If you wanted,
You know, it's easier just to call him, man. You just made that. That's a lot of work. That's a deep thought. All right. One thing I'd like to do is I'd like to thank the three gentlemen up here. They, spent their own personal time. They prepared this. They came here. They shared their deep knowledge with you. They don't have to do this. And, this is how our industry gets better and how it grows. So I would like to thank all of them for doing that.